DevOps. Auf die Ohren und ins Hirn. Ein Podcast rund um DevOps.
Von Luca in Gianni
und Dirk Söllner.
Welcome to a new episode of DevOps auf die Ohren und ins Hirn, or in English, DevOps from your ears straight to your brain. Usually this is a German language podcast, but sometimes we make exceptions for international guests. My name is Luca Ingianni. I'm a DevOps consultant, trainer, and coach, trying to get teams to work together better and create better products for their customers. And I host this podcast together with my colleague Dirk Söllner, who, however, is on holiday at the moment. Today, I have the pleasure to introduce my very old friend and exceptional engineer, Adrian Ratnapala. Adrian works as a site reliability engineer at Google in Sydney, Australia. Since I have only a vague idea of what site reliability engineering is, I figured it would be a good idea to invite him and ask. Hi, Adrian. Thanks a lot for agreeing to be on this show.
Hi, Luca.
Would you like to introduce the listeners to yourself?
Yeah, so as you said, I'm a site reliability engineer at Google. I have been some sort of engineer. Well, I guess I've been some sort of computer engineer for perhaps 6 or 7 years, whenever it was that I moved to Munich first, where I did various things in the contracting industry there. But I am not going to inflict my German on the audience, so I'm afraid that we're going to have to speak English. However, as time moved on, I decided to move back to where my family and other people were. And that led to an opportunity to join Google as an engineer. And it turned out to be that I joined as a site reliability engineer, which I was also not very clear about what that meant until I joined. And maybe that's a bit of a theme, because I think that we can describe what it is, but the realities depend on where you've been, and DevOps and SRE and all of these things. I think they're very context dependent.
Okay, yes, thank you very much. Let's start with a first question, which we ask all of our guests, which is, what is your definition of DevOps? Given that there is no common definition, what's yours?
I guess I don't have one, because I think in terms of SRE, and I'm aware of people doing DevOps, and it often sounds very similar to what we do. And I am willing to go with the definition that I find in, or at least the description that I find in Google's book about SRE, which is that SRE is essentially a subset of DevOps. That it's a more specific term, because at Google we invented this concept of SRE many years ago, and DevOps wasn't as famous as it is now, or maybe it wasn't a term that was in use. And in time we found that SRE is part of that. But I believe that there's probably different people will mean different things. So I think sometimes people talk about DevOps being about unifying development and operations, and SRE specifically about having operations specialists. So those are not really compatible. But other people seem to use DevOps in other ways, and I won't try and second guess that.
Okay, so you said SRE is about having sysadmin specialists. What does that mean? How do you work? Because the idea in DevOps is to have cross-functional teams, where you have people of different specialties, maybe software developers, maybe sysadmins, etc., work together towards a common goal of, delivering functionality to the customer. Is that not what SRE is aiming for, or what is SRE aiming for?
SRE, I guess one way of putting it is that we'd be very leery of that term sysadmin, because a sysadmin brings to mind the idea of someone who knows a lot about Unix, incanting commands into their big server in the back end, which was the way things might have happened in the 1990s or whatever. The concept of SRE is that model doesn't scale to a company like Google, or increasingly to other companies. And so you need to ease that burden of having to do actual sysadmin work by treating operations as an engineering discipline, so that you can actually build out things that do things at scale. We can drill into the details of what that actually means at time. But the idea is you do SRE so that you engineer away the need to do sysadmin. And the kinds of engineers who specialize in that are SREs. And it doesn't mean that developers don't also do that. But if we're talking specifically about SREs, then they are specialists in operations.
Okay, so now you've explained to us what SREs don't do, but what is it that they actually do?
Right. I was afraid you were going to say that I'd explained to you what SREs did, and I didn't think I had. I did say that we do engineering to maintain operations, so which is quite a big, vague thing, but anything that will be useful to keeping a service running with a minimum of what we call toil is valid engineering work. So that might mean working on the actual software, the actual server that we're standing up and you're fixing bugs or something like that. But it might also mean working on automation for rollouts or working on the monitoring and all of these things.
Okay, so you just touched on this concept of toil. Can you explain that a bit more for the benefit of the listeners?
Yeah, toil is any kind of work that is, well, one way of thinking of it is that it's generated by an event that will recur. So if, one kind of toil that we would definitely want to eliminate would be if a machine goes down, then you would have to restart the server on another machine. And we don't have to do that because there are long-standing automation systems of automation that prevent that. But that would be a very clear and simple version of toil. Anything where someone has to do some work in order to keep the system working, but that doesn't overall improve the system for the future would be toil.
So any kind of like running in place, if you will.
Yeah, you could call it that.
Okay, and if I understand you correctly, the way you deal with toil is that you try to eliminate it by automating it away.
Yes, I'm hesitant to say it's necessarily automation, although I guess it depends on how broadly you mean that term. I mean, if you have some kind of toil that is created by a bug in your server, then you want to fix the bug.
Okay, that's interesting. So toil is like any kind of manual work, and of course, removing the root cause for the manual work in the first place would also be a valid way to remove toil, and arguably actually a better way, I suppose.
Yeah, it's better if you can simplify a system than to complicate it. And automation is an interesting thing because it both simplifies and complicates.
Okay, and how does Google deal with that sort of thing? Like, how do you make these kinds of trade-offs, those kinds of decisions? How do you decide what to automate or what to maybe eliminate, which means going further upstream and probably changing the actual product in some way?
I guess it mostly depends on opportunity. It's not always possible to fix a bug. It's not always caused by a bug or something like that. And I think that's a very case-by-case thing. If you're facing a problem, which is usually a source of toil, then you have to consider what the different solutions are and what solutions are available to you. So if it is that you could could fix a bug or remove a component entirely, then sure, you do that. But in the real world, it usually is rather that you need to tweak some configuration, and it's more common that lines of code get added than removed. That's just the way of the world.
Yeah, fair enough. Let's stay with those with automation for a second, because I was wondering, what are the trade-offs of automation? You just touched on one where you said, if I automate something, that means, I've just made the system more complex. Are there other things that come to mind, other things that you've observed over the course of your work?
Yeah. I mean, it makes things complex in one sense. If I say write a script in order to run some other program repeatedly, then my script is new code and a new system of failure. But it simplifies in another way, because now maybe that script is you just run it and you don't have to worry about all of the different parameters of the thing that it's running, because that's now automated. I think that's a very familiar thing to anyone in the field. I don't think that's different in Google versus anywhere else. And I think another thing that's universal is that over time you do get more automation. So that trade-off always, at some rate, moves in the direction of having more things that live at higher levels and take care of things that are at lower levels. The trade-offs are that overall complexity. And I think another important trade-off is the human knowledge. Because especially if a new engineer comes in, then they will day-to-day deal with things at the level of whatever automation is used day-to-day. And they'll learn things at that level, which could be a problem if to fix things, if to do their job, they need to understand things down at the lower level that has been partially automated away. So I think the best automation is one that provides a non-leaky abstraction. And that's not easy to achieve. So one of the trade-offs is how much leakiness should you tolerate in order to get the benefits of not having to do the toil.
Yeah, I understand. And I suppose that's particularly important at a place with just that much infrastructure as Google has, where you must abstract things away or you'll just drown in mountains of physical servers or whatever, don't you? So how do you think, is Google in any way special compared to other organizations, even other large corporations? Or do you think the same problems would exist elsewhere, just at a smaller scale?
I can't speculate about all organizations, especially large organizations, which probably do have many similar problems and solutions to us. One thing that is different between certainly Google and some other organizations at a much smaller scale, would be that doing things manually would almost never mean SSHing into some server and incanting Unix commands, as I talked about before, on that server. Because the most obvious way in which Google has scaled up, and the most massive way in which Google has scaled up, is the number of machines. So you simply can't do that. There are ways you can if you need to in order to fix something, but I've never had to do that. Whereas that might be an acceptable way of doing things if you're small enough, that you only have a few servers, and it has the benefit that the people who go and do it know how those machines are set up.
It just scales really badly, which might be okay if you're small enough.
Yeah. So I mean, there's always this thing that the nature of your scalability solutions, the automation or whatever else you do in order to be scalable, needs to be some sort of match to your actual scale. And I guess what I'm saying is that one of the reasons that a small organization might not want to use a larger scale solution is just that knowledge problem, that if the manual toil isn't so big because you're small, you have a small number of servers or whatever, then you have a chance of getting your hands dirty and learning. Your engineers have a chance of learning exactly how things work. We do that same thing, but at a higher level, not down at the level of what's going on the servers.
Okay. However, we talked about maybe a better way of eliminating toil would be to make the actual problem go away. For example, fixing a bug. How would that work in the environment you work in? If you observe something, there's toil because of a bug that you encountered in your production systems. How would you go about getting that bug out of the system? How does the communication flow between you and any colleagues that need to be involved?
Right. Let's consider a scenario where you're an SRE and you get paged because of some high error rate for some service or whatever, and you go and you deal with this alert by, I don't know, you maybe you turn up some more capacity because you found that something was running out of memory or whatever. You just do a quick fix to make it work. Whatever you do, you've made the problem go away, or maybe you drain traffic from one place to another so that it goes away for now. And further investigations ensue. If however we did it, we found that there was, or we suspected that there was a bug, then by that time we'll be talking to the developers. But it could be something where the SRE themselves can see what the bug is. If servers are crashing and you have a core dump, then you can see the line of code where it crashed, and you might see there's an obvious failure to check a null pointer or something like that. In which case, the best thing to do to fix that is to just go to the line of code, fix the null pointer check, and suggest that this is a fix to the bug, and you go through the process of verifying that it really is a fix. But that might be all there is. But more usually, it's something subtler. Often it's something subtler, and in which case it's generally a question of communicating with the people who wrote the software in the first place, which is the dev team. And although SREs are not software developers, we are in close contact with the developers of the software. It's not like I suppose if you're in an open source world, you might have an open source package that then you use, and then you're relatively disconnected from the developers. But we're talking about things going on within a company. So even if you are separate from the developers, there's two-way communication, and you're part of that cycle of iteration.
I see. Okay, so is there even like a regular meeting or something where you talk to your developers, or how does that work? How well do you know these people? How easily can you talk to them if you feel that you need to?
Very easy. I mean, for me, the biggest hurdle is that I am in Sydney, and no developers for any of the things that I work on are in Sydney. There are regular meetings. So I'll give a little bit of a structure. There are various. This is not how what I'm talking about now is not how things are done at Google, because things will vary between teams, and the numbers of people and things will vary between teams. But I have worked on things where my team was responsible for various different services, and then there were particular SREs who had particular responsibilities for one or two services. So I would go to a meeting with the developers of that service that I was particularly responsible for every week. And there we would usually discuss all of the outages for that service, as well as our plans for the future in terms of operations, because that's a sync that the developers have specifically for into SREs. We are very much on the same page with regard to where the service is going, at least on that area of interface where operations and development are closed. Developers have other concerns, long-term feature work and stuff like that. That doesn't necessarily concern us, although it might. But insofar as anything does concern us, then we have very tight loops of communication.
Okay, and one other thing that I was wondering about is that if you find some source of toil, who is actually responsible for dealing with that? Is that you? Is that the dev team? Especially if it's something that has, that originates somewhere in the code, a bug, as we said before.
Yeah, I mean, it depends on what the solution is and what the next step of work is. But if it originates in the code, it's generally something that the devs will have to deal with. I mean, even if it's something where I can go and fix the bug, then the reviewer of that bug fix will be one of the devs of the service, because almost always, because it's just logical, right? If you change someone's code, then the developers are the people who review the change.
Yeah, I was wondering about that. How accepting are they of fixes that come from further downstream from the SRE team, for instance?
Oh, that's fine. Once that change is there, the reviewer is going. What they have is a change. It's not like you think, it's a change from an SRE, it's a change from a dev. It's just a change that can be reviewed on its merits.
so far we've been talking about issues that come out of the system, like bug reports, toil, whatever. What I'm wondering about is how close are you to your users, your customers? Because I imagine that the way you do your work greatly influences the experience that users have, especially in terms of responsiveness of applications, that sort of thing. How closely are you embedded into, or how close to those conversations with customers are you, and do you feel it's working well enough?
Again, I can't speak for all SREs, but all of the services that I have worked on have been backends of something. And that might mean that it's a backend of a backend of a backend, for all I know, because all of the services I've worked on also have many internal clients, which will relate to the end users in whatever way. So our team, our SRE team, or my SRE teams, has actually has very little direct visibility to the end user. Sometimes we can infer what an end user might be seeing if we look at a request at the actual content of a request, which we rarely do, and is better not to. But we're not directly facing a user; we're facing internal clients. So our focus is on understanding their needs as well as possible, and transitively that gets us to the user. But for us, we usually infer. If a RPC is taking a minute to complete, a request is taking a minute to complete, then possibly that means that a user is having a slow end user experience. It doesn't necessarily mean that.
So we were talking about feedback, and I'm wondering what kind of things you measure. How is monitoring implemented at Google? I don't mean particularly the mundane, boring stuff, but on a higher level. What's interesting about the way you view this data that's coming out of the system?
Right. So I mean, what gets monitored is an enormous amount of things get monitored. It partly depends on just on a technical level at what you really mean by monitoring, because there are thousands of metrics that every server will collect, not just at Google, of which a certain amount get collected by the monitoring services, and different things alert at different levels. But in general, for any service, you'll have a dashboard with all kinds of different measurements, which will vary depending on the service. So I'm not going to talk too much about that, except that there'll be obvious boring stuff, as you said, such as the rate of requests and the number of errors. When you tie that together, I guess a more concerning question than what you monitor, which ideally is everything, is it really? It's a lot. A more concerning question than what you measure is what you alert on, and what will get a human's attention, and what you might look at that high level. So there's a kind of tension between a white box approach and a black box approach. And the movement is towards the black box approach. Describe them both a little bit, which is you might have a system where requests come from a client, effectively an end user. We usually don't talk to the users directly. And that then gets put on a publisher subscriber queue, just for an example. There's many things that could it stays in that queue and goes off to some other system and gets processed there, and finally lands in a database. So now you probably do monitor every part of that. You monitor the front end server, you monitor the queue, the publisher subscriber queue, you monitor the database that holds that queue, you monitor the system that reads from the queue, you monitor the database that system writes to, all of those things. And at any point, something could be going wrong, and you might have metrics for when to alert somebody about it. And that would be white box monitoring. And then the black box says, what does the end user care about? So an error from the front-end server would be an obvious case of what a user might get if there are enough errors. It's not just a blip. Another thing might be might be, in a white box, it would be the publish subscriber queue was broken. But in a black box situation, it's the end user wrote some data, but then failed to read it back after some time that they would have expected it to become consistent.
So in essence, you're not concerned with the technical details. You're just concerned with the effect that this defect or whatever has on the user, the consumer of this product of yours.
Yeah. So what black box monitoring, I guess, is what it sounds like, which is that it measures things from the outside, and yes, is usually done as close as possible to reference to what we think clients care about. So if you've defined a service level obligation, then you want to be measuring how well you're doing that. So by service level obligation, I would mean not just measure the error rate, but we have got, we are serving at 99% availability a few minutes. And then you measure whether you've met that SLO. And then you can define other SLOs such as the freshness or whatever it is, something that you think that a client will be able to see, and you alert on these things. And the idea is that way you're not creating unnecessary toil, because you don't alert on things the client doesn't care about. The trade-off there is that if you got some sort of alert saying that the black box is broken, then it just tells you that it's broken. Whereas if you had a white box alert, it tells you what is broken, which is helpful when you.
But on the other hand, I suppose it's noisier and perhaps less helpful as far as the customer is concerned.
Yeah, I mean, this is why the movement is to reduce the amount of white box monitoring and increase the amount of box monitoring, because as systems get larger, more complicated, there'd be more noise if you do too much.
So yet again, you're just sort of moving up the layers of abstraction, aren't you?
Yeah, I think so. I think, the thing is, we do have a lot of white, and there's nothing wrong. It's just that as time goes on, the trend will be the other way.
Interesting. Yeah, and I think it makes sense to view it from that perspective. Speaking of SLOs and things like that, I read about something that I found interesting, which is error budgets. Can you speak to that for a little bit?
Yes. There are multiple different kinds of budgets, such as an error budget or a latency budget. I guess it's what it sounds like. If you've promised to have 99.9% availability over a month, then that means there's a certain number of errors that you could serve. And what could you say? That you use that budget to find out if you have a problem. So if you have a serious outage, then you might burn through your entire month's error budget in a few minutes, if that error budget was small enough. And that's one way you can make the argument, well, now that was a serious problem. Whatever it was is something that needs to be prioritized over some other thing, which might also have caused some errors, but wasn't as far out of expectation as necessary. I'm sure there's more detail that people could go into, but I think that it would be that these things become clearer when you're actually doing it.
Yeah, it's interesting. If you read Google's SRE book, they say that there is an error budget and you ought to spend it.
Yes.
If you're required to have a 99.9% availability, it's actually not a good idea to get your availability up to 99.99, because that just means you've been overly cautious.
It means you've been overly cautious, and it means that you make people dependent. People will not be dependent on your published SLO. They will be dependent on what you actually deliver, which is frequently above what you claim you deliver. So this is a common problem that you have at Google that I think is particularly maddening with latency, because you will have a system where your database normally responds in a millisecond, and your system is basically limited by the latency of the database. But sometimes it will respond much more slowly. And so you know this, and you publish an SLO saying that we will respond in 500 milliseconds at 99% of the time. But actually, you're responding in 5 milliseconds 99% of the time. And people will get used to that. And when you start responding in 100 milliseconds, you will get people coming to you saying, "Why is the system broken?" And you can't blame them for that. Well, it's just a reality of life. So
Exactly. You've created an implicit contract and you violated it.
that's right. And so it's good to align your SLOs with reality. So one way of putting it is, if you have an error budget, you can spend it. But probably the more common way, or the better way, is to make sure that you've got the correct SLO. So in fact, this is a project that I did last quarter, if I remember correctly, which was starting with actually measuring what our performance was over various clients and over various variables, and using that to write a new definition of our SLOs. It's surprisingly non-trivial work, because first you have to measure it, then you have to use that, consolidate all of that information to define what you think your SLOs should be, and then you actually have to measure those things, which in this case required measuring new things that we weren't measuring in the past, in order to make that alignment happen.
Interesting. I was going to ask, how else do you observe that SLOs are and error budgets are sort of actively managed? Like, if I'm taking your example from before to an extreme, and you say that yes, your database will respond to queries within 500 milliseconds, should you just always respond within 500 milliseconds just to give nobody false ideas?
As an add delay loops, I've been tempted to do that. There's a little bit of that in the SRE book. In fact, I think contains a famous case of our lock server, which has deliberate outages in order to keep people honest. But yeah, more often you don't do that. I mean, you don't want to introduce unreliability to your system just because you can. But if, for example, with a system like this database, one thing that might be is to just engineer the problem away. So you have a database that normally responds in a millisecond, but might respond in 500. So maybe it might be a solution to be talking to two instances of the database, independent ones, and then you can guarantee that. Well, then you have a very good chance that at least one of them will respond within 20 milliseconds at least. So now you can offer a more reasonable SLO than this enormous 500 millisecond one. And so there's different solutions depending on what the actual problem is and what opportunities arise. But yes, sometimes the solution actually is to deliberately not offer the performance that could be offered, but only unreliably.
Okay. As sort of the last topic I wanted to explore with you today, I would like to talk a bit more about the people who are part of those systems at Google, because any sufficiently non-trivial system will always have humans as one component of it. And especially at Google scale, where you have a lot of technology, how do you balance that against the humans who must essentially necessarily be part of that system?
Are you talking about how humans learn about the system, or
maybe sometimes humans are the source of errors. Sometimes humans are the corrective element. And I'm just wondering how something that is that technology dependent just because of scale as Google deals with the fact that humans will still be a part of that, and you as SRE are obviously the sort of most crucial part of that system that delivers, I don't know, whatever part of whatever service.
One thing I'd like to emphasize is that SREs and developers both run services. It's in a frontline situation where serving things for the user, it's not just SREs. It's SREs and developers both. I guess the relationships between humans and the machine or the machines are different. There are many different dimensions on which we can talk about. So we've talked about automation and how that creates a stack of different things to learn, which people will mostly learn the top layers of. And so, and then we've also talked about monitoring and people being alerted. So that almost puts people into a feedback loop as part of the system. Do you have any? Do you know which angles you are most interested in talking about?
No, not really. I was just exploring this just because it's such a crucial aspect that, every non-trivial system contains humans as one or more of its elements, from aircraft to cars to web servers.
Okay. I guess, see, this is the Munich München coming back, because that's a lot easier to understand in terms of aircraft and cars, I think. But it's true that that an aircraft or a car has an operator who's a driver or whatever, or a pilot. And I suppose in that sense we are operators, but we are not drivers or pilots of the system, right? So the person who's driving your Google experience is really the user. But we are there as part of the system that keeps it reliable. And ideally, I guess I haven't thought about it in this way, so I'm making things up a little bit. But I think that aspect of our role is huge, but it's also the very thing we want to minimize because it is by definition toil. Because it's what happens as part of the system being reliable. If the human being is part of the system being reliable, then what you would have preferred would be that the human being, the engineer, had previously engineered something so that the system was just reliable on its own or without human intervention. So we are part of that system because computers ultimately are only computers and they can't take care of themselves and they do need people to polish the gears and stuff. And another aspect of that, though, is that we actually do want some toil. We want to be getting paged every so often, partly so that we get practice at dealing with debugging our systems, but also so that knowledge that we gain can go back to our engineering efforts.
Wow, that made perfect sense. I found that fascinating to hear, and I think this is an excellent place to leave it. Adrian, thanks so much for being on this podcast. I think our listeners will find it very, very interesting, and I know that I enjoyed it greatly. So, thanks again.